Problem number 5. In the given figure, the particle 1 of charge plus 6 microcoulomb and particle 2 of charge minus 2 microcoulomb are held at separation L equal to 10 centimeter on an x-axis. If particle 3 of unknown charge Q3 is to be located such that the net electrostatic force on it from particle 1 and 2 is 0, what must be the x and y coordinates of the particle 3? So let's see the given figure. What is given in the question? You have two charges Q1 and Q2, and in the figure they mention 1 and 2. So 1 and 2 refers Q1 and Q2, and these two charged particles are separated by a distance L, which is equal to 10 centimeter. And the magnitude, that means the values of charge 1 and charge 2 is given as 6 microcoulomb and minus 2 microcoulomb respectively. Now what you are going to do, you are going to take the third charge and you are going to place that charge exactly on the x-axis. By that, the net electrostatic force on the third charge by charge 1 and 2 on the third should be equal to 0. That means the interaction of the first charge on the third, the interaction of the second charge on the third should be equal to 0. Clear? So you have to find the exact location to place the third charge. So when you place the third charge, by that the net electrostatic force of charge 1 on 3, charge 2 on 3 should be equal to 0. So we have to find its exact location on the x-axis. So here I can deal the answers directly, but we have to know. So if you see the figure, we have 3 locations to place the third unknown charge. The first location is here. That means left hand side of Q1. The second location is between Q1 and Q2, and the third location is next to charge 2. That means this is the third location. So we have 3 options. So in these 3 options, only one option will be exactly matched. By that, the net electrostatic force of the particle 1 on 3 and particle 2 on 3 is 0. So let's consider the first location. So what I am going to do, I am going to take a positive charge. Let's take positive or negative, both will give the same answer here. Okay, so what I am going to do, I am going to consider my third charge is an unknown charge. So let's take that unknown charge is positive charge. So what I'm going to do, I'm going to place that positive charge here. I'm going to place that positive charge here. And you can see your Q1 is positive and Q2 is negative, because you can see Q1 is positive, Q2 is negative. So what I am going to do, I'm going to place a positive charge in this location 1. So this is my first location. So let's check what is the net electrostatic force of 1 on 3 and 2 on 3 should be equal to 0. So that means this is our third charge, right? This is our third charge. So that means the interaction of charge 1 on 3, the interaction of charge 2 on 3 should be equal to 0. That means the Coulomb's law we have to apply. Clear? So let's see. So if you place the positive charge in this location 1, what will happen? The positive charge get repel with this positive charge, because your Q1 is positive here and your Q2 is negative. So what will happen? So we took the positive unknown charge. I told you already, you can consider either positive or negative. Both will give the same answer. So I will explain with positive, and then later on I will give the information about negative also, because both will give the same answer. So let's consider my third charge is a positive charge. So if I place that positive charge in this location 1, what will happen? Positive charge get interact with the positive charge. What will happen? It will repel. Am I right? That means the force 1 on 3 will be in this direction, because this magnitude is greater and it's a positive charge. So what will happen? Let's consider a small charge. The third charge is small charge. What will happen? It will repel. So likewise, we have to find the interaction of the second charge on the third charge. So your second charge is positive and your third charge is your second charge is negative, your third charge is positive. What will happen? Force of attraction will be there, because we know the unlike charges attract each other, like charges repel each other, right? So this is positive, this is negative, but the most important thing, what is the distance between Q3 and Q2, it's very large. So when you have more distance, but when the distance is greater, the electrostatic force between the 2 point charges should be weaker, right? So based on that, what will happen? You have the force of attraction, but the force of attraction will be very, very small. So this is the arrow where your force of attraction will be there. So this is based on the charge 2 on 3. So now you can see my left hand side arrow is greater because the distance between Q1 and Q2 is very shorter. That's the reason this arrow mark is greater. But the distance between Q3 and Q2 is very far. So that's the reason the force of attraction is weaker here. So, but if you see, this location is not suitable. Why? Because when you find the force interaction of 1 on 3 and 2 on 3 should be in same size. That means the arrow mark should be in the same size. Then only you can say the interaction of charge 1 on 3 and 2 on 3 is 0. But that means you can see the right side arrow is smaller, left hand side arrow is greater. So this place is not suitable for placing the third unknown charge. Now the second option, what I'm going to do, let's we check here. So what I'm going to do, this is our positive charge. What will happen? This is my second location. First location is not possible, right? Because it is not 0. So now I'm going to test with the second location. So let's replace our unknown third charge here. So this is our third charge, Q3. So what will happen? The interaction of positive, what will happen? Q1 on Q3. Q1 is positive, Q2 is positive. What will happen? It will repel. So that means this is F1 on 3. So let's we check the interaction between Q2 and Q3. Your Q2 is negative, Q3 is positive. So that means it will attract. So here you have 2, 3. Again, you can see both arrows are in the same direction. So what will happen? It is not gives the information about the electrostatic force of first charge on the third and the second charge on the third is not 0, right? Because why? If you want to get 0, both side arrow, the arrow should be opposite to each other with same magnitude. That means the same length. But here, when you place the third charge in the middle of second charge, middle of two charges, two arrows are in the same direction. So that means this location is also not possible. So only one option. We have the location 3, which is next to Q3. So let's we place our third charge. Our third charge is positive. So I'm going to test this location. Now you can see Q3 on Q1. Your Q1 is magnitude wise, it is very greater. But what is the distance? The distance is very, very big, right? So when the distance is greater, your force of repel will be weaker. So that means it will repel in this direction. So this is based on force of 1 on 3. And then you can see your Q2 and Q3 are very closer. Based on Q2, your magnitude is very small. So attraction will be this direction. Now you can see F of 2 on 3 will be in this direction. Now you can see the arrow mark. So here the right hand side arrow and the left hand side arrow are closer to exactly in same length. So that means this place is exactly suitable for placing our third unknown charge in this place, in this location. Clear? I told you already, if you consider negative charge, you will get the same answer. Because if you place negative, what will happen? Negative and positive will attract. So the arrow marks will be this direction, right side direction. And also negative repel. So arrow will be this direction. So that means one side it is a very lengthy line, other side the line will be smaller. So it's not possible for the first location. Even when you consider the negative charge in the middle, same two arrows will be in the left direction, not possible. But when you place the negative charge in the third location, you will get the same answer. That's what I told you. Whether you consider the positive point charge or negative point charge, the third location is exactly suitable for getting the answer of interaction of 1 on 3 and 2 on 3 is 0. Clear? So that means this location is exactly possible. Now we came to know this location is exactly apt for placing our third charge to get the electrostatic force of 1 on 3 and 2 on 3 is equal to 0. So but most important thing, we have to give some distance. That means the distance is very, very important. So what I'm going to do, let's we consider the distance between the charge Q2 and Q3. So let's we take the distance between these two charges. Let's we take L0. That means Q1 and Q2 distance is L. The distance between Q2 and Q3 is L0. So now we have to find what is the x coordinate and y coordinate of the third charge. That means x value, y value we have to find. So for that, I have to consider this location. So here F23, which is equal to F13, right? So I'm going to apply the Coulomb's law for these. So apply Coulomb's law for charge 2 and 3. So what you will get? Coulomb's law says about K, magnitude of the second charge, magnitude of the third charge, over what is the distance between 2 and 3? The distance between second charge and the third charge is L naught. So it is L naught square, because what Coulomb's law says, F, which is equal to K Q1 magnitude Q2 magnitude over the square of the distance between the two charges. So that means the distance between Q2 and Q3, because I am applying the Coulomb's law for the second charge and the third charge. So the distance between charge 2 and 3 is L0, so L0 square. So likewise, I have to apply the Coulomb's law for 1 and 3. So by that, what we will get? K magnitude of Q1 magnitude of Q3 over what is the distance between 1 and 3? You can see the distance between 1 and 3 is L plus L naught, right? So the distance between 1 and 3 is L plus L naught. So L plus L naught whole square. Clear? Now you can see Coulomb constant K, both sides we can cancel each other. Likewise Q3 get cancel each other. So now what I am going to do, I am going to separate charges one side. I am going to separate the separation distance one side. So what I am going to do, let's we just move this Q to this side. Let's we move this L plus L naught square to the left hand side of the numerator. So what you will get, Q1 magnitude over Q2 magnitude, which is equal to L plus L naught the whole square over L naught square, right? So the charge value Q1 is given as 6 microcoulomb and the charge 2 is -2, but we are going to consider only the magnitude of the charges, so we no need to worry about this negative. So the Q1 takes the value of 6 microcoulomb and Q2 takes the value of 2 microcoulomb. So I am going to substitute the value here. So 6 microcoulomb, what is micro? 10 power -6 over -2 multiplied 10 power -6. So magnitude of the negative is positive, right? So right hand side we got L plus L naught the whole square over L naught square. Now you can see micro get cancelled with this micro. So magnitude of this minus is positive. So we can cancel this. So we will get 3, which is equal to L plus L naught the whole square over L naught square. So now what I am going to do, I am going to take the square root on both left hand side and right hand side. So if you take the square root, what you will get? So here we will get √3. When you take the square root for the top, this becomes L plus L naught. When you take the square root for this bottom, it is L naught. So now we can split the right hand side into 2. So √3, which is equal to L over L naught plus L naught over L naught. Clear? So now the right hand side L over L naught plus 1, and the right hand side we have, so left hand side we have √3. Now the main aim, we have to find the value of L naught. Once you find the value of L naught, it's easy to get the answer for the x coordinate and y coordinate, because the value of L is already given here as 10 centimeters. So the only thing, once you find the value of L naught, it is easy to find the x and y coordinate of the third charge, right? So we have to find the value of L naught. So what you have to do, we have to rearrange this equation in terms of L naught. So what I'm going to do, I'm going to move this term to the left hand side. So √3 minus 1, which is equal to L over L naught. So we have to find L naught. So I'm going to take this term to the left hand side of the numerator. I'm going to bring this root 3 minus 1 to the right hand side of the denominators. By that, what you will get? L naught, which is equal to L over root 3 minus 1. So what is L? Which is 10 over root 3 minus 1. So let's see what is the answer. So 10 over root 3 minus 1. I got the answer here as 13.66. Better we can round at the number. So I got the value of L naught here as 13.66. So we no need to go for these fraction numbers. So better we can round at this number. So approximately we can take this number to 14 centimeter. Clear? Now you can see we have to find the location of the third charge. That means we have to find the coordinate of third charge. That means x value and y value. So the third charge is exactly sitting on the x-axis. So what's the value of y? Which is 0 centimeter. But what is the value of x? L plus L naught. Am I right? So what's the value of L? 10 plus 14, which is equal to 24 centimeter. So the x coordinate of the third charge is 24 centimeter. The y coordinate of the third charge is 0 centimeter. So this is the answer. So x value and y value of this third charge is 24, 0. So this is the answer. So the unit here is centimeter. So this is the answer for this question. That's it. Thank you.